Now that we've become more comfortable with factoring quadratics of all types, special cases, having to factor out a monomial, greatest common factor, when the coefficient's 1, when the coefficient of x squared is not 1, we've done a lot of practice with those. Now we're going to make one small adjustment to make these equations and to be able to solve them. I would say personally, I think the hardest part of it, we've already practiced. This application of it is a little bit, I think, closer to something you're more comfortable with going in. But that's for you to decide, I guess. So if we take a look here, we're going to apply what is called the zero product property. We must do a couple things. The first thing we have to do is write the quadratic equation in standard form. Standard form, remember, in this case, will be the following. It will be ax squared plus bx plus c equals 0. This will have to be in this particular form. Okay? Once we have it in standard form like that, we have to factor the quadratic if possible. If it's not factorable, we will not be able to use this method, and we'll get into other methods down the road here. As I said, if it's not factorable, we'll get into those methods later on. However, the ones we have right now will be able to be factored. Once it's factored, we'll use what's called the zero product property to solve the actual quadratic equation. So if we consider a and b to be real numbers or binomial expressions, if a times b is 0, that means either a has to be 0 or b has to be 0. And that comes from the fact that if you multiply two numbers together and get 0, then one of them has to be 0. So we'll see that here. That's the main application of what we have going on here when we solve these. So if we look at these two examples, let's start with the one on the left because it's going to be more straightforward right now. Coefficient of x squared is 1. It's already in standard form. It's already equal to 0. So we will have to simply factor. I want to use blue here. X and x, and then I need factors of 18 that combine to give me 3. And what stands out to me is 3 and 6. And it looks as though I'll need -3 and +6. So I'll have x minus 3 and x plus 6. So I factored that. I have the quantity x minus 3 times the quantity x plus 6 equals 0. So I'm multiplying two things together, and I get 0. Here's where we apply the zero product property. This means that x minus 3 equals 0, or x plus 6 equals 0. Now I'm sure we can all solve these equations. We would add 3 to both sides here. We get x equals 3. Or we'd subtract 6 there. We get x equals -6. And you must tell us both of these answers. That will be the complete solution. X equals 3 or x equals -6. We'll get into the special names of these during class tomorrow. But that's all we have to do. That's what we mean by the zero product property. If we look, however, at the example on the right, we can just tell by looking at this one, there's a little more work involved, which is fine. We have to get it in this form, x squared plus 3x minus 18. It has to look like that. So I'm going to combine like terms. I'm going to subtract 3x from both sides. That'll leave me with 2x squared minus 20x plus 45 equals -5. I'll add 5 to both sides. I have 2x squared minus 20x plus 50 equals 0. Now, as we learned in class today, we look at these. Is there a common factor? And the answer to that question is yes, 2. So I have 2 times the quantity, x squared, minus 10x plus 25, all equals 0. So now we can factor the inside here. So I have 2. Now, this looks like it might be a special case because I have the first term is a perfect square and the last term is a perfect square. Let's take a look. Factors of 25 that combine to give you 10. Well, to me, that's minus 5 minus 5. So we have it factored. We've gotten it back up here. We're in good shape. Now, with that being said, if we set this stuff equal to 0, I have 2 equals 0. I have x minus 5 equals 0. And I have x minus 5 equals 0. Now, this obviously is not true. 2 cannot be equal to 0. And I have x minus 5 equals 0 twice. We only have to do one of those. We would end up with x equals 5 as our answer to this particular quadratic equation. So that's all we have. We'll continue to practice these. Those should be your set examples with all the steps we need. We'll continue practicing those tomorrow during class.